Step 0, factor everything completely first. The bottom is a difference of squares. And then step 1, what are our non-permissible values? X can't equal -5, and x can't equal 5. Are those going to be vertical asymptotes or holes? Vertical asymptotes, both of them. So you're going to have a vertical asymptote at x equals 5 and x equals -5. 2. Nothing simplified, so we're still dealing with this equation. Are we going to have horizontal asymptotes or oblique asymptotes? Horizontal. Again, the way that you can tell, or maybe you're used to saying, hey, if the degree on the top is the same as the degree on the bottom, I always have a horizontal asymptote. Or you can just look at the highest power in this case, which is x squared. We have -2x squared on top. We have a positive 1x squared on the bottom. This simplifies to y equals -2, and that will be your horizontal asymptote. Step 3. Let's find all of our intercepts. Find your y-intercept by plugging in 0 for x. Plug in 0 for x, can you see that you're going to get 0 over -25, which is 0? And your x-intercept, plug in 0 for y. Again, an x-intercept or a fraction is only equal to 0 if your numerator is equal to 0, and so you get 0 again, which makes sense because the y-intercept was 0. That will mean your x-intercept is 0 as well. But what's important here is that we found out that that's our only x-intercept. Now, when you go to graph it, so start by adding all of your asymptotes. So in this case, we have one. That is not a dotted line. There we go. At -5, 1 at 5, and 1 at y equals -2. We can plug our x-intercept on there. And so this is the only point that we have so far. So we need some more points in order to graph it completely. We know that that's our only x-intercept. Our vertical asymptotes split our graph up into different domains. Can you see that your domain is less than -5, in between -5 and 5, and then after 5? And so that separates it into 3 sections of x values. If we wanted to find out what happens in the first section, we can choose a value, say -6. And if I go up to my equation and say, well, what happens when I plug in -6? -6 squared is 36 times a -2. I'll get -72 on the top of my fraction. Plug in -6 here, I'll get -1. -6 here, I'll get -11. That simplifies to -72 over 11, which is 6 point something, -6 point something. So now on my graph, I can say that point is going to be somewhere here. -6, -72 over 11. Because it's in this section, we can now say graph is going to approach your asymptotes. So this section will look like this. So similarly, we're going to need to find a point in this section. So I'm going to choose x equals 6. If I go back up to my equation, can you see that the top will still be negative 72 when you plug in 6? 6 plus 5, that'll be 11. 6 minus 5, that's 1. We get the exact same point, negative 72 over 11. So I'll label that point on here as well, 6 comma negative 72 over 11. And because we have those asymptotes there, we can draw our graph towards the asymptotes. Remember that a horizontal asymptote does not necessarily mean that a graph can't go through it. We've got a point there. What I need to find out from this point is our graph going to go up towards this asymptote or down towards this asymptote? So if we look at some points inside here, maybe I'll take 4 and negative 4 and check those values when you plug them in. So can you see on the top, if I plug in 4, I'll get negative 32. And on the bottom, if I plug in 4, this will be 9 and this will be negative 1. So I'll get negative 32 over negative 9, which is positive 3 point something. So I can label that 4 comma 32 over 9. And if I try with negative 4, well, negative 4 would still give me negative 32 on top. Here I'm going to get 1. Here I'm going to get negative 9. Same thing, it'll be positive 32 over 9. And so based on those points, your graph is going to be approaching the asymptotes on the way up. Because if it went through those points and approached the asymptote on the way down, can you see that you would get another x-intercept? And we don't have any more x-intercepts. We only have the 1. So a couple of things that may connect to some stuff that we did in chapter 1. You see that it bounced? Does it make sense that your x-intercept has a multiplicity of 2? So that idea came up again and sort of bounced on there. And so this shape makes sense for the middle part of this graph. Questions for this one? Number 4, the domain for this one is x can't equal negative 5 and x can't equal 5. But x can be anything else.